Okay, so we're taking this example on page 5 in the white packet, and we're looking at the first 5 terms. So we need 1, 2, 3, 4, 5. Anytime they list U1, we put it in the first blank. So the first term is 4. To get from term to term, let me just rephrase what I said a moment ago. It's saying to get to the next term, you double the term before it, and then add 3. So that's what the rule is. So double 4 and then add 3, what do we get? 11. Double 11 and then add 3. Yes, 25. Double it and add 3. 53. And finally, 109. So those would be the first 5 terms of that sequence. Now what we talked about yesterday was where would those numbers show up? Where would the 2 and the 3 show up when you're looking at the pattern? What I'm saying is, let's pretend we didn't know the formula, and I just gave you the sequence, and I said, okay, find the formula for me. Tell me what the ratio is. In other words, what's the multiplier? Let's call that R, like we have all chapter, right? We've been calling that an R. And what's the D? So this doesn't just have an R or a D, it has both, an R and a D. Let me change the, well, let's just leave it go. So what we do is we go ahead and find the differences. We find what this sequence is growing by. There's a similar problem back on in section 1.2, the green worksheet, number 4. Talked about this one yesterday. So if you want to go back and try that problem again after we discuss this, maybe you'll figure it out. So what is this growing by from 4 to 11? It goes up by 7. From 11 to 25, goes up by 14. Okay? From 25 to 53 is an increase of 28. And then finally, from 53 to 109 goes up by 56. So when you look at those differences in red, they're not the same. So we can clearly see that it's not an arithmetic sequence. All right? However, they have a special pattern to them. And what is that special pattern that they have? They're multiplying by 2 every time. Okay? So what we call that, what I call that, is the common ratio of the differences. These are the differences. They are multiplying by 2 every time. That's not a 0.2, that's times 2. All right? That number shows up in the formula right here. The fact that it's doubling is right there in the formula. Now, to figure out how the little plus 3 shows up, how you would figure out that plus 3, you kind of just do this. You say, okay, what if we didn't know this, and this is all we had, right? What if we thought that to get from here to here, you just doubled 4? You don't, right? If you did, if you doubled 4, where would you land? You'd land at 8. How far off are you to get to 11? You're off by 3. So you need an adjustment. You need a shifter. You need a little number that's going to shift the sequence by 3, and that's why we tack on the plus 3. So my goal in this example was to show you the formula of a shifted geometric sequence. It's geometric because it's multiplying, but it's shifted because it's also adding or subtracting sometimes. Okay? My goal was to show you a formula and find the sequence, and then look at the sequence and see where those numbers are in the formula. See where the R comes from, and then the little number on the end. Okay? So that is our shifted geometric sequence, and we're going to